Hello guys, let's solve the Ensu Monday for class 7 and these are regarding load word instruction data path. Well, before solving the question Ensu Monday for class 7, please have a look under some overview of load word instruction in the data path. So as all of you know, the load word instruction looks like this, and the purpose of this instruction is load data from a memory address defined by this part to a register defined by this part. Well, so to execute this, what you have to know, what the data contain in the memory address and how you calculate the memory address with this part. So here is a constant digit 32 and a register. So using these two, first you need to calculate the memory address and then you have to know what data contain that particular memory address defined by here. And after that you pick the value from the memory address and write it to the particular register. Okay, so what I want to say, first you need to know what the data have in this memory address. Well, I give you the memory address this contain a value of -1, for example. Well, so you know, now you have to know how to calculate this memory address. Well, there are two parts. The first part contain a constant, that the second part is the register address. So every register contain a value, particularly here is 0, that means 0 register always contain 0. Well, so you just need to add this and you will got the memory address. And ALU perform this addition operation for you to find the memory address. And this is the register where you need to write this. So if you know the value that contains the particular register, so you pick this value and store it to the T2 register. This is the load word instruction. Well, if you convert this instruction to a corresponding binary code, 32-bit MIPS code, you will find this code that we extensively discussed in the last class. So this is your instruction, this is the register, and this is the another register, and this is the offset. Well, let's move to the data path. So many of you ask in the Moodle, what is the purpose of the arithmetic logic unit? Well, I will explain all the thing in the data path again. So the first thing, keep in mind, we need to find the address from where we want to pick the data to a particular register T2. The first thing you have to do, you have register, here is this register 0. So in this port we will find the register 0, and the output, we read the data, it always 0. So source A is 0, and you have the immediate here. So sign extend the convert this 16-bit immediate to a 32-bit sign immediate. If it is positive, all 0 followed by the remaining bit. Okay, so now come to the ALU. Basically ALU performs all arithmetic logical operation and shift arithmetic and logical operation. Particularly it's perform the operation based on the ALU control, 3-bit ALU control. And if the control says the value is 0, 1, 0, that means you have to the ALU perform the addition operation. So here the immediate value comes out, here the value from register comes out, and these two are added, and here you will get the memory address from where the load word instruction want to pick the data. And here it is given that this particular memory address contains this value. So now the data path will write this value -1 to the particular register T2 here. and that's it. Well, now let's solve the Ensure Mondai. The instruction looks same, load dot instruction. The register are changed, the offset value are changed, and also this change. So to calculate the memory address, you need to know what contain the T1 register. I give you, it contain this value. So if you add these two value with the offset, you will get the memory address from where you need to pick the value to store it the 7 register. So if the value is 100 and you add the offset 4, you will get this address, and I also give you that particular memory address contain this value. Well, let's convert this instruction to a 32-bit. It looks like this. The load dot instruction and the register file and the immediate part. Well, first the register file will receive the address of two register here, one register, and it contains the value 100. The immediate comes here is 4 is come here. This 1000 and 4 are added because the LU control says, hey, this is the signal for addition, and here you will get the memory address, and this is the memory address. And in the question I also give you what value contain the particular memory address here, A, B, 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 B. So you will read the value here and just write it to the destination register here, 20, this S1. That's it. So the value of S1 now changed with the new value of this after execution of this command. I think you guys understand. Thank you very much.